This is the last video of applying the washer method to find the volume of a revolution. The next module will be the slicing technique. So what we have here is find the volume of a solid obtained by rotating the region bounded by the curves y equals root x plus 1, y is equal to x cubed plus 1, rotated about the line x equals 2. And we want to find the volume of the solid of a revolution. The first step, as usual, is to find the points of intersection. So we have y is equal to root x plus 1, and we have y is equal to x cubed plus 1. To find the points of intersection, we let y equals y, and that means we get root x plus 1 is equal to x cubed plus 1. Now, it's hard to use algebra to solve for x, so what we're going to do is we're going to guess. So what would be a suitable guess? Well, let's start with something easy, like x equals 0. Putting x equals 0 into the left-hand side, we get root of 0, that's 0. 0 plus 1 is 1, equals 0 cubed plus 1 is 1, 1 equals 1, that works. How about x equals 1? So we get root of 1 plus 1 is equal to 1 plus 1, and we get 2 equals 2, that also works. So x equals 0 is a point of intersection. Plug it into y equals root x plus 1 to get a corresponding y value. And we get y is equal to root of 0 is 0, 0 plus 1 is 1. Plug x equals 1 into y equals x cubed plus 1. And we get the y value, y is equal to 1 cubed plus 1, y equals 2. So the intersection points are x equals 0, y equals 1, x equals 1, y equals 2. All right, the next step is to sketch the bounded region and a typical washer. The most important thing is to define the outer radius and the inner radius. The outer radius in this case is the distance from the axis of rotation, which is x equals 2, to the closest point, to the farthest point on the horizontal slice that we've drawn. And that distance is going to be 2 minus the x value corresponding to y equals root x plus 1. The inner radius is the distance from the axis of rotation to the closest point on the horizontal slice that we've drawn. That's going to be 2 minus the x value corresponding to the cubic function y equals x cubed plus 1. So we're going to need to solve for x in terms of y. Y equals root x plus 1. If we solve for x in terms of y, after some algebra, we'll get x is equal to y minus 1 all squared. And y equals x cubed plus 1, solving for x in terms of y, we will get x is equal to third root of y minus 1. Now, the inner and outer radius is so important that I want to emphasize this. The outer radius is the distance from the axis of rotation to the farthest point of the horizontal slice that we've drawn. That's going to be x equals 2 minus the x value corresponding to y equals root x plus 1, and we found this x value, x equals y minus 1 squared. The inner radius is the distance from the axis of rotation, x equals 2, to the closest point on the horizontal slice, and that is the x value corresponding to the cubic function x equals third root of y minus 1. So the outer radius is 2 minus y minus 1 squared, and the inner radius is 2 minus third root of y minus 1. And we've drawn a typical cross-sectional slice, and we add up these slices, these cross-sectional slices, in the y direction to find the volume of the solid of revolution. All right, so now let's summarize what we've done. The outer radius outer, is 2 minus y minus 1 squared. The inner radius is 2 minus the x value corresponding to the cubic function, that's 2 minus third root of y minus 1. A cross-sectional slice is going to be pi times outer radius squared. The outer radius is 2 minus y minus 1 squared, all squared, minus the inner radius, which is 2, minus third root of y minus 1, all squared. And now let's also define the volume of a washer at a point y, where y is between 1 and 2. So volume of washer at a point y, at a typical y point, where y is between 2 and 1. Differential volume is going to be pi times 2 minus y minus 1 squared, all squared, minus 2 minus third root of y minus 1, all squared, times dy. And that's the volume of a washer. Now the total volume of the solid will be the definite integral. Volume is integral pi times integral from 1 to 2. This is y equals 1 up to y equals 2. These are y values. We're integrating with respect to y. And that's going to be 2 minus y minus 1 squared, all squared, outer radius squared, minus inner radius squared. 2 minus third root of y minus 1, all squared. Integrated with respect to y, we're adding up these cross-sectional slices in the y direction. All right, now we have to do the computation. So setting up the definite integral and finding the volume. Here's the volume of the solid in terms of a definite integral. Now we have to expand the integrand, simplify, and integrate. So that's going to be the heavy-duty stuff. So pi times integral from 1 to 2. Let's open this up. We have 2 minus y minus 1 squared, all squared. So square the first term, minus 2 times the product of the two terms. So 2 times 2 times y minus 1 squared, plus y minus 1 to the fourth, minus 2 squared is 4, minus 4, third root of y minus 1, plus y minus 1 to the 1/3 to the power of 2, that's y minus 1 to the 2/3, close bracket, and let's stick a dy here, that's dy. All right, let's simplify this. Volume is equal to pi, integral from 1 to 2. We have 2 squared, which is 4, minus 4. That's going to cancel, so let's cancel that out. And simplify, we get minus 4. Let me simplify this a bit more. So pi integral from 1 to 2, minus 4 times y minus 1 squared, plus y minus 1 to the 4, plus 4 third root of y minus 1 minus y minus 1 to the 2/3 and integrated with respect to y. Now we're going to be applying the reverse of the power rule, so we should really write this as, instead of writing third root of y minus 1, we should write it as y minus 1 to the power of 1/3. Let's do that. So we have y minus 1 to the power of 1/3. All right, now we have to integrate. So volume is equal to pi times -4, reversing the power rule and applying the reverse of the chain rule, which is U substitution, we get y minus 1 cubed, divide by 3, plus y minus 1 to the 5, divide by 5, plus 4 times y minus 1 to the power of 1/3 plus 3 over 3, that's 4/3, divide by 4/3, and it flips, we get 3/4. We reciprocated times 3/4. Minus y minus 1 to the power of 2/3 plus 3 over 3, that's 5 over 3, reversing the power rule. Dividing by 5 over 3 is the same as multiplying by 3 over 5, evaluated from 1 to 2. So now we have to put it in. We have to put the upper limit in and the lower limit. Putting the upper limit in, we get 2 minus 1 cubed, that's 1, so we get minus 4/3. 2 minus 1 is 1 to the 5, that's 1 over 5. Plus, let's cancel this 4 with this 4, and 2 minus 1 is 1, 1 to the 4/3 is 1, so that's plus 3. Minus 2 minus 1, minus 3/5. Minus. Now, let's put the lower limit in. So putting the lower limit is y equals 1. Well, plugging y equals 1 is going to give you 0 here, it's going to give you 0 here, 0 here, and 0 here, 0 everywhere, and 0 here. So it's just minus 0. That was easy. So now we have to simplify this. That's going to give us pi times -4/3 minus 2 over 5, because we have 1 over 5 minus 3 over 5, plus 3. All right, so what we have is volume is equal to pi times -4/3 minus 2 over 5 plus, let's write this as 3 over 1. Take common denominator. The common denominator is 15. 3 goes into 15 5 times minus 4, that's negative 20, adding these fractions. 5 goes into 15 3 times minus 2, that's minus 6. And 1 goes into 15 times 3 is 45. If we add these numbers, we're going to get 19 pi divided by 15. If we decimalize this, this is the value for the volume of the solid of revolution, the volume, 3.98. And the units will be units cubed. Could be centimeter cubed or meter cubed, for example. Now, let's do a bit of review on the integration that we've done, namely the U substitution. So you will see that we did integral of y minus 1 to the fourth with respect to y, and we got y minus 1 to the power of 5 over 5 plus c. The reason for that is U substitution will let u equals y minus 1, differentiate both sides, du is equal to dy. We also had integral y minus 1 to the 1/3 dy. So the result was y minus 1 to the 4/3 divided by 4/3 plus c. And again, the rule is U substitution. We let u be the inside function. U is y minus 1. Differentiate both sides, we get du equals dy. More generally, if we have a case like integral ay plus b to the power of n dy, as long as n is not equal to minus 1, we will get ay plus b to the power of n plus 1 divided by n plus 1 divided by a plus c. Why do we divide by a? It's because we're reversing the chain rule. It's because of the U substitution. So let's go over that. Let u be the inside function, ay plus b. Differentiate both sides, we get du is equal to a dy. Divide by a, and what we get is dy is du divided by a. And that's why we have a here, for exactly the reason that we have a here. It's U substitution. All right, thank you.